The second unit we covered was properties of matter. It covered the difference between a chemical and a physical change, chemical and physical properties, how to calculate density, and mass and volume. Alright, matter was one of the terms that we learned in this chapter. Matter is anything that has mass and takes up space. And this question is asking you what to calculate. What is the density of this liquid? Density equals mass divided by volume. So you need to first find the mass that's given to you. It says 22 grams, and then calculate the volume. When you calculate the volume of a liquid, you have to read from the bottom of the meniscus, otherwise you're going to get the wrong answer. And then you have to figure out your scale. So the bottom number is 60, the top number is 70. And you need to figure out what they're counting by. So it looks like they're counting by ones. If you count from the bottom, that's 61, 62, 63, 64, 65, 66, and 67, which means the volume is 67 milliliters. And then you can use that number to calculate your density. Density equals mass divided by volume. Density equals 22 grams divided by 67 milliliters. And you're going to get 0.3283. Remember, you need to round up to get two numbers after the decimal place, which is going to give you 0.33 grams per milliliter. In the next one, we have the volume of a regularly shaped object is our first step. So you have 5 centimeters, 4 centimeters, and 2 centimeters. You find the volume by taking length times width times height. So I'm going to take 5 centimeters times 4 centimeters times 2 centimeters. And 5 times 4 is 20, 20 times 2 is 40. So you're going to get 40 centimeters cubed. And you get cubed because you have centimeters listed 3 times, which is why you have to have cm3 because it's a 3D object. And now that we have our volume, we also have our mass. It says it's 50 grams. Now we can calculate density. Density equals mass divided by volume. So density equals 50 grams divided by 40 centimeters cubed. And if you take 50 divided by 40, you should be getting 1.25. So density equals 1.25 grams per centimeter cubed. This next problem is going to show you how to calculate the volume of an irregularly shaped object. So it combines calculating the water volume and then having to do the displacement of an object. So the first thing you need to do is find the volume of the first liquid, and that looks like it's 50 milliliters. And the next one, like we did on the first one, first you need to check and make sure you're looking at the bottom of the liquid, which is kind of where this dashed line is here. You also need to figure out your scale. So it looks like they're going from 70 to 80, and they're counting by 2. So it's right in the middle between 70 and 80. That would be 75 milliliters. And then to calculate the volume, you need to calculate the displacement. You're going to subtract. You're going to take 75 milliliters minus 50 milliliters. Should give you 25 milliliters. But we know that the rock is not a liquid. Milliliters measures liquids. But we also know that 1 milliliter equals 1 centimeter cubed. So you can convert 25 milliliters to 25 centimeters cubed because the rock is a solid. And now we have both of the numbers we need to calculate density. So density equals mass divided by volume. We're going to take 15 grams divided by 25 centimeters cubed. which should give you 0.6 grams per centimeter cubed. Another thing we practiced was recognizing the density of liquids if they're combined in a container. The most dense liquid should be the one that sinks, so that's going to be the red liquid on the bottom. The least dense liquid would be the yellow liquid on the top because it's floating. One of the last things we did in this chapter was looking at the difference between chemical and physical changes. So remember, physical changes will not change what the substance is. Chemical changes will change what the substance is. Physical changes are fairly easily reversible, and chemical changes are not easily reversible. So my hint for you guys was, if you say, is it still a pop can, or is it still a popsicle, and you say yes, that's a physical change. If you say, is it a pop can, and you say no, that would be a chemical change. So in this first one, some questions you could ask would be, is it still a popsicle? Does it still taste the same? And hopefully you answer yes, that would be a physical change. It also says we're going to list what properties have changed. So if a popsicle melts, it's a state change. You're going from a solid to a liquid. You have a change in volume. You have a change in density. And you have a change in shape. In the picture on the right, is it still a pop can? Yes, so it's a physical change. And the only thing that's going to change is its shape. The first one I'm going to do here is the rocket. And we know that this is a chemical change because you can't reverse. You can't take all those gases and put them back into the fuel. So it's a chemical change. We know it's a chemical change because the evidence is that you have light, heat, odor, you even have a change in color. Even milk up at the top. You cannot take soured milk and turn it back, so we know that that's a chemical change. And some evidence of a chemical change would be that it has a bad smell, so an odor. It might even have a color change if it's been sitting for a really long time. And the tablets on the right side, once those tablets have fizzed, you can't easily reverse that to what the chemicals were before. So it's a chemical change. And we also know it's a chemical change because there was fizzing, which means those bubbles. In the Statue of Liberty, you cannot reverse the Statue of Liberty. You can't turn it back to the color it was. Those chemicals have changed. So you know it's a chemical change because you saw a change in color. And that's the end of the properties of matter unit.